Hello, my dear students. This is Ikhlaq sir, your physics faculty. So, we are going to discuss one beautiful problem in Newton's laws of motion, and that is block on smooth inclined plane. Okay. So, this is a block. The mass of this block is given to you, that's equal to m, and this block is placed on a smooth inclined plane. Implies that the force of friction here in this problem will be taken as 0. Okay. What we are supposed to calculate is, number one is that we have to calculate normal reaction, and number second is that we have to calculate acceleration. All right, these are the two things we have to calculate. Okay. Now, what will be the first step before solving the problem? What will be the first step? The first step is that you tell me how many forces are there on this block. Okay. So how many forces are there on this block? Obviously there are two forces on this block. Number one is normal reaction, and that normal reaction will be always perpendicular to the plane of contact. This is the plane of contact, POC, and normal reaction, see that it is perpendicular to the plane of contact, isn't it? Okay, force number second on this block will be weight, and the weight is always vertically downwards, like this it is. It's always vertically downwards. Okay, M into G. This is the weight on the block. So how many forces are there on the block? There are two forces on the block. ठीक. नंबर नेक्स्ट इज दैट, जो आप नेक्स्ट चीज़ मुझे बताएंगे वो ये है कि ये ब्लॉक किस डायरेक्शन में एक्सेलरेट करेगा. ओके, सो ऑब्वियसली यू विल से सर इट विल एक्सेलरेट down the inclined plane. Along this direction it will accelerate down the inclined plane. Okay, now there should be a force along down the inclined plane which will make the block to accelerate in that direction, isn't it? तो इस दिशा में, इस डायरेक्शन में एक फोर्स होना चाहिए जो फोर्स इस ब्लॉक को क्या कराएगा, एक्सेलरेट कराएगा. क्या है कोई फोर्स वहाँ पे? हाँ, वहाँ पे तो एक फोर्स है. वो कौन सा फोर्स है? दैट इज एक्चुअली द कंपोनेंट ऑफ द वेट. So what next I will do is that I will resolve this mg into the rectangular components. तो इस mg के कितने कंपोनेंट्स होंगे? ये mg हमारे पास है बेटा, तो इसके कितने कंपोनेंट्स होंगे? इसके दो कंपोनेंट्स होंगे. ओके, इट विल हैव टू रेक्टेंगुलर कंपोनेंट्स. ओके, सो वन कंपोनेंट विल बी along this direction down the inclined plane. Okay, and another component will be along this direction. ठीक है जी. Okay, if this angle is theta, then this angle will be also equal to theta. This angle is theta for you. Why? The reason is that the angle between two lines always equals to angle between their perpendicular. See that this is one line and this is another line, and theta is the angle between them, and this line is perpendicular to this line, and see that this normal direction is perpendicular to this line. So we say that the angle between two lines always equals to angle between their perpendiculars. Okay, so this is mg. So this mg will have how many components? It will have two components. One component along this direction will be obviously mg sine theta. Another component along this direction will be what? It will be mg cos theta. Is that clear or not? Is that clear? So first and foremost, there are two forces on this block. Force number one will be normal reaction, which is always perpendicular to the plane of contact. This is our plane of contact, and this is the normal reaction. Number one. Number second is that weight, it is always vertically downwards. So there are two forces. Next, what I have done is that I have resolved this mg into two rectangular components. One component is this mg sine theta, and another component is this mg cos theta. Okay, now it's quite clear from this diagram that this normal reaction and this mg cos theta, they will balance each other, isn't it? The reason is that in this direction there is no acceleration of the block. Okay, and what about this mg sin theta? Is mg sin theta का क्या role होगा? It will simply accelerate the block down the inclined plane. Okay, so next what I'm going to do is that I'll write down what is the normal reaction. The normal reaction is obviously equal to what? It is equal to mg cos theta. Okay, and we are done with this a part. And b is that we will have to calculate the acceleration. Obviously acceleration will be equal to sum of all the external forces divided by sum of all the masses, which is Newton's second law. Now tell me what is the net force on this block? This is the block. Okay, so what's the net force on this block? That's obviously only mg sine theta, because n and mg cos theta, they are going to cancel each other. Okay, so we have just one force on this block, and that is mg sine theta. So let me write down here mg sine theta divided by what? Divided by m. Okay, now obviously this m and m is going to disappear, and we are left with this a equals to what? A equals to g sine theta. So we have two important results here. Number one is the normal reaction. Let me highlight it for you. So this is normal reaction, which is equal to mg cos theta, and result number second is acceleration of the block, which is g sine theta. I hope that this problem is absolutely clear to you. Okay, now we have the b part b in this problem, and that is something like this. Okay, that is something like this. So this is a block. Now this block is at the top of this inclined plane at the point A, and it slides down from the point A and eventually reaches the point B. Now what we have to calculate is that calculate the velocity of the block at the base and the time taken as the block moves from A to B. Okay, the block moves from this point A to this point B along this path. Okay, and what we are supposed to calculate is that we'll have to calculate this velocity at the base of the inclined plane, number one. Number second is that as the block moves from A to B, what is the time taken by the block? That's what we are supposed to calculate. All right, all right. Okay, okay. The first and foremost thing is that you will tell me what will be the acceleration of the block as it goes from A to B. That will be obviously g sine theta. We have just calculated that this acceleration a equals to what? G sine theta. Okay, this is the acceleration of the block, isn't it? Okay, now tell me one thing, is this acceleration variable or it is constant? Obviously it is constant. Now when the acceleration is constant, the situation demands equations of motion. And हम यहाँ पे कौन सी इक्वेशन यूज़ करेंगे? हम यहाँ पे एक इक्वेशन यूज़ करेंगे, दैट इज वी स्क्वायर माइनस यू स्क्वायर equals to 2as, isn't it? Okay, we had to calculate the final velocity, so I am going to write down here v square, and the initial velocity, see that it starts from rest, this block starts from rest, तो इसका मतलब ये है that the initial velocity of this block is equal to what? That's equal to 0. So let me write down here 0 is equal to 2. इस a के बदले क्या लिखेंगे हम? इस a के बदले लिखेंगे हम g sin theta, और इस s के बदले क्या लिखेंगे? That is simply s. And what is the value of this v? V will be equal to what? It will be equal to 2g square root of twice g sin theta multiplied by s. So this is another important result for us, that the velocity of the block at the base of inclined plane will be something like this. Okay, and we are also supposed to calculate this time taken to reach the base. We are done with this velocity at the base, and next we have to calculate what is the time taken by this block to reach the base. Again I will use an equation of motion. Which equation that will be? That will be this equation, s equals to ut plus 1 by 2 at square, isn't it? Equation number second. Okay, so the initial velocity is obviously equal to 0, so this displacement comes out to be 1/2 of at square. Okay, all right. Now I want to calculate t here, so t will be obviously equal to square root of 2s divided by a. Now tell me one thing, what is the value of a? We have just calculated that. Obviously sir, we have calculated that, and that a is equal to what? That is equal to g sin theta. तो मैंने यहाँ पे a के बदले क्या लिखा? g sin theta. So the time taken by the block to slide down the inclined plane is something like this, that is square root of 2s divided by g sin theta. Okay, I hope that this part is also clear to you. Now we have one more part in this problem, that is part c. One more part in this problem, that's part c. Okay, in this video part what we are going to do is that हमने यहाँ पे क्या करना है, जो ये ब्लॉक है जिसका मास m है, it is thrown in the upward direction, up the inclined plane. All right, it is thrown up the inclined plane. So that means the initial velocity of the block, see that is directed upwards. That is directed upward. This is the direction of the initial velocity. Okay. Now you know that the force on this block down the inclined plane will be something like mg sine theta, and as a result of which the retardation here will be some in this direction. Okay. Okay, the block will retard. Now the question arises, why the block will retard? The answer is obvious. Body goes in the upward direction, up the inclined plane, and the force on the block is down the inclined plane. ठीक है, एक बात आप हमेशा याद रखा करेंगे, that is whenever the velocity and the acceleration are anti-parallel, the body will retard. Okay, so the body is going to retard. Now tell me one thing, what is the value of that retardation? That will be obviously equal to g sine theta, isn't it? We have just calculated that a is equal to g sine theta in this problem again. Okay. Okay, that is great. That's absolutely great. Okay, so next thing we will be doing is that stopping time. तो in the kinematics आपने पढ़ा होगा, I am sure that कि stopping time जो होता है, equation for the stopping time is something like this, u divided by a. Okay, tell me one thing, what I will replace this a by? So this a will be replaced by what? It will be replaced by g sine theta, and this is our stopping time. All right, and now we have to calculate the stopping distance. Stopping distance is equal to u square divided by twice a. ये जो इक्वेशन है बेटा, ये हम पढ़ते हैं in the equations of motion in chapter kinematics. All right, now u square divided by 2, and this a will be replaced by what? It will be replaced by g sine theta. And another important result here, number one is stopping time, and number second is stopping distance. All right, I hope that this problem is absolutely clear to you. Okay, see you next time with one more beautiful problem of physics. Okay, take care of yourselves.